Perfect. No, we're not going to need our Chromebooks today. We're going to go ahead and do a lesson because we're going to go ahead and review what we did yesterday. So yesterday we went over our decimals activity, right? And I still saw some of you guys that were able to identify the theorem here. Some still need a little bit of help. So therefore, I'm going to go ahead and officially introduce it to you guys and give it an official name. Now, this theorem that we did yesterday is called the secant. We were exploring it through our table and the values that we multiplied and we made equal to each other, right? Now, guys, today we're going to go ahead and go over the two theorems because they're very, very similar to each other, yet a little bit different, just because our second segment is going to just not be a secant, but it will be considered a tangent instead. It's just going to be moved into another different place. Still the same concept applies, okay? So with that said, let me go ahead and bring you guys up. Here's my beautiful tangent. Now my tangent intersects my beautiful circle at how many places? Exactly 1 point. Now my chord here intercepts my beautiful circle at how many points? 2. So that is my difference between my tangent and my secant. So I'm going to have those two lines. My first line that we have, my two pairs of lines are my secant and my secant. So I have two secants present. Whenever they both intersect at my point E, they're going to be outside of my beautiful circle. If that happens, then the reason or the way that we're going to go ahead and solve for the measurements is that we're going to go ahead and make our measurement for my beautiful secant, AE. We're going to multiply it by its exterior piece, its exterior segment. And we're going to go ahead and make it equal to the measurement of our second secant multiplied by that exterior section, that exterior segment DE in this case. So once we are able to find the missing part, we can go ahead and create our equation, and then we can go ahead and solve for that piece and then find the measurement of the whole secant if needed. So go ahead and copy this one down so you can have it in your notes. Secant product theorem. If two secants intersect in an exterior of a circle, so we have them here, they're going to go ahead and intersect. Then the products of their lengths of one secant segment and the external segment equals to the product of the other secant segment and its external segment. So my beautiful secant segment, AE, multiplied by BE. We have a party next door. CE multiplied by beautiful DE, that exterior. Secant product theorem. And what this states, I'm going to go ahead and have my entire secant multiplied by its external length. And we're going to go ahead and make it equal to the other secant and multiply it by its other external length. Now, what is my first secant? From A to C. Now 5x, 5 plus x, and that is AC. 5 plus beautiful x. Now that we're going to go ahead and multiply it by its external piece, and its external piece is 5 in this case. So AB multiplied by 5. And we're going to go ahead and make it equal to the other secant. My other secant in this case is 12 from A to E, which is AE. Make it equal to 12. And this is multiplied by its beautiful external piece. Let me go ahead and highlight its external piece. My external piece is from A to D. Multiplied by AD. What is the AD? What is the measurement of AD in this case? 6. Okay. Now we've established our equation properly. We're going to go ahead and now solve for that beautiful equation. So what do I do here? Multiply. So we're going to go ahead and distribute. We already multiplied a binomial by a monomial. So it gives me 25 plus 5x equals, what is 12 times 6? 72. And then becomes a 2 step. So subtract 25, subtract 25. I'm left with 5x equals, what is 72 minus 25? What is it? 47. There you go, 47. I didn't hear you guys. And then divide by 5. X equals 9.4. That is correct. Now, that was my first question. Are we done? Yes, no, maybe so. We have to find the length of each secant. So my first secant that we already found is right here, which is what? 12. And my second secant, AC, I have to add 9.4 to 5, which is 14.4. So how do we get that 14.4? 5 plus 9.4. Not too bad, huh? Not too bad. Let me go ahead and save an image. Are you guys ready?
Yeah.
Jaden, are you ready out there? Yeah? Make sure you guys copy this down, please. All right, let me go ahead and clear. Ready for our next example? Our second example. This one? Yeah. I know. It's my Drake, my pelon. I don't know who placed it on my desk yesterday. All right, so let's go ahead and set up my beautiful equation. I have secant and a secant. Now, what is the first secant that I have here? Which one do you guys want to do first? SP, so SP. What is the measurement of SP? 8 plus 6, which is what? 14. Now, this is going to multiply by the exterior portion or the exterior piece of that secant. Let me go ahead and highlight my secant first and then highlight my beautiful exterior. Here's my secant. What's the exterior piece of that secant? RP, from R to P. So from R to P, and it measures 6. Perfect. Equals my entire secant, UT. UT is UP equals X plus 7, and it's multiplied by my external piece. What's the external piece? TP, and that and it's what? 7. All right, let's go ahead and find X and see what you guys get. All right, so what do we get for our beautiful X? What do we get on our left side? X does equal 5. Now, how do we get there? 84 equals what? What would be the result for my right side? There you go, 49 plus 7x, or 7x plus 49. Then it becomes a 2-step, subtract the 49 on both sides. We're left with 35 equals 7, divide by 7, and we're left with X equals beautiful 5. Are we done? No. We have to go back and substitute. So what is the length of SP? 14, it's already given. And my length of UP? 7 plus 5. 7 plus 5. I was going to write X equals. There you go. X equals 5. So therefore, my whole entire segment is beautiful 12. All right. Any questions on this one? Okay. So how do we feel about secant? Okay. Now, this time we're going to go ahead and have now our secant tangent. Yes. Go ahead and copy this one down. Because our tangent doesn't have those 2 sections or those 2 beautiful segments created by its entire length. We only have this little piece that is created by that tangent outside right here. What we're going to go ahead and do is that we're going to go ahead and follow the same procedure with our secant. Our tangent, however, we're going to go ahead and multiply it by itself. So we don't have that second segment that we're going to go ahead and multiply by inside of our circle. Therefore, we're going to square that value. So AD is my beautiful secant. BD is that exterior piece. And we're going to make it equal to, there's no secant, there's a tangent. And we're going to go ahead and multiply it by that exterior piece again, which is that same length, right? That same tangent segment. Now, sometimes you're going to see it as an entire length, we're only interested on analyzing it or looking at it from where it intersects the circle to where it intersects that beautiful other secant, okay? We're only interested in that piece, okay? So if one example pops up, I don't know, somewhere in the exit ticket or something, we're only interested in looking from where it intersects in the circle or on the circle right here, all the way to where it intersects with that other secant, okay? All right, let's go ahead and copy this to you. Okay, so here we go. No. Here we go. All right. Example number 3, we're going to go ahead and find the value of x. It says right here, given the diameter of Earth being 8,000 miles, a satellite's orbit is 6,000 miles above the Earth. Right here, its range shown by SP is the tangent segment that is shown in the image. Our job is to find the beautiful value of x, knowing that we have our beautiful secant and we have a beautiful tangent line or a tangent segment in this case. Okay. All right. Let's go ahead and copy this down in your notes first, and then we'll go ahead and take it by parts. We'll take it by parts. Take it by parts. Here we go. So given the diameter of Earth as 8,000 miles, we have it here. Nice and beautifully already given in the image. We're going to go ahead and assume that our diameter is exactly 8,000 miles. Now my diameter should be going through my center and it intersects my beautiful circle at 2 different points, right? So it's a little piece of it. Now, whenever we have the diameter in a circle, we're going to have the satellite orbiting, and we're going to go ahead and imagine that it's orbiting exactly through the diameter, okay, that satellite. So if that happens, whenever we cut it and we put it into a 2D shape, okay, we're going to have that beautiful satellite at this point S, and it's going to be a distance away from my beautiful Earth. And what is that distance away from it? 6,400. So let me go ahead and write that out. Now, our question here is that we want to know what that tangent segment is. Do we know what that measurement is? No, we don't know what that measurement is. So therefore, if I don't know, it's going to be automatically x. In our equation, it's going to be x squared. But in the image, it's going to be x. Okay. Now let's go ahead and build our beautiful equation. What is my beautiful secant? Imagining that my satellite is orbiting right at my diameter, around the diameter of my beautiful Earth. It's right perfectly, not like on the top of the Earth or the bottom of the Earth, right to the center. So imagine that this is a whole secant. What would it be? It would be the measurement of SA. So SA would be 14,400. Now, what does this number come from? 8,000 plus 6,400. Yes. So, because my secant is the whole entire length, right? What is the exterior piece? SE. 6,400. Okay. Same procedure that we were doing with the secant. The entire length of my beautiful secant times the external piece. My right side is what's going to change. Since we don't have another secant, we only have that tangent segment. We're going to use that measurement in the exterior, which is my tangent, SP, and it's going to be squared. So this time it's going to be x beautiful squared. All right, let's go ahead and multiply what is 14,400 times 6,400. You guys have beautiful calculators. 160,000 equals x squared. Now I have a beautiful x squared. How do I solve it? 16. I thought I heard 16. 60. 160?
Yeah.
Okay. There you go. All right, now I have a beautiful x squared. How do I get rid of that beautiful x squared? Square root. My inverse of squaring is square rooting, so therefore I get x equals, what is this? 9,000, beautiful 6,000. So my value of x is 9,600. Not too bad, huh? And we had a real oral application here. All right. Let me give you guys a beautiful exit ticket. Let me go ahead and save and clear. Did you guys need it? Let me go back. There you go. Let me go ahead and pause here.